Hello everyone, good morning and good afternoon. Thank you for joining this webinar. My name is Emma Trach and next to me is my colleague Tommy Liu, and he will be presenting this webinar today. Today's topic is the eDesignSYNC for NX, and this is an integration of the NX software together with Moldex. So we are hoping that you will like this webinar. After the webinar is finished, we will have the Q&A session. So please stay tuned, and now I'm passing the microphone to Tommy.
Hello everyone, my name is Tommy. I'm the product manager of eDesignSYNC for NX in Cotech. It's my honor to demo Moldex 3D eDesignSYNC in this webinar. If you have any questions during my presentation, feel free to type in the text box. I will answer those questions in the Q&A section as well. Okay, here we go. In my presentation, there are three parts. Part A, I will tell you what is injection molding and what is eDesignSYNC. Part B, I will demo the basic functions and the design tools in eDesignSYNC. And then I will interpret the benefit of eDesignSYNC in design optimization. Okay. In part A, I want to talk about what is injection molding. This is an injection machine, and the injection molding is one of the most common methods of converting plastics from the raw material to a plastic product. Injection molding is a black box. Nobody really knows what happened inside. And we analyze injection molding by four phases: filling, packing, cooling, and warpage. Okay, cavity filling is a key step because cavity filling is a process of moving metal film in 3 dimensions and a tension phenomenon. And non-Newton flow and coupled heat transfer are usually issues in the filling process. In general, during the filling stage, any product defects will occur if there are design flaws, improper process, or improper material. Okay, and then packing is analyze the packing or holding process in the injection molding. And then cooling system is very important in injection molding. An ideal cooling system can cool and solidify plastic parts, and avoiding unwanted deformation occurred during mold ejection. Finally, warpage is the summarization of all effects in whole procedure of injection molding, and it can predict the product deformation. Okay, so what is eDesignSYNC? Nowadays, many different CAD files are used by designers, so it may cause data loss when users export CAD file to another CAD environment. So eDesignSYNC for NX is an easy-to-use interface embedded in NX, bringing a seamless workflow from design to simulation. I had heard that some of the other software may make simplification on the product which integrates with CAD software, but we never do that. With complete support of a Moldex 3D eDesign, designers are able to synchronize design change and check the performance with professional injection molding simulation in order to efficiently resolve the difficulties in designing and manufacturing with their familiar CAD environment. Okay, and eDesignSYNC has supported NX5 to NX9. Okay, I will show you several common defects occurring in injection molding. including weld line, short shot, air trap, and warpage. First, weld line is a line formed by two different meltfronts joined together during the filling stage. It will decrease the structural strength of the final product and increase product surface defects. If you encounter this problem, we suggest you increase the melt temperature or change the gate location. Okay, and then short shot is incomplete filling of the mold cavity. When short shot occurs, increasing the injection pressure or changing the gate location may solve this issue. Okay, and then air trap is formed by converging meltfront trapping a small bubble of air. It may occur at multiple locations inside the cavity. You can conclude that an air trap will occur at the location where meltfront comes in all directions. Regarding this problem, we have to improve vent location. Okay, warpage in injection molding is the result of unequal volume shrinkage of material throughout the geometry of the piece as it cools from a melt to a solid state. Okay, variation of temperature of pressure will induce the variation of a specific volume and density of a polymer. This variation induces the warpage of injection molded plastic parts. There are a lot of factors affecting plastic part warpage, such as material selection, part design, mold design, and process condition. So we want to know what kind of a process we should do to fix this issue. Designers would design their parts and performing an injection molding simulation with eDesignSYNC for checking the design of the products are suitable or not. Examine the analysis result. If there are some defects in this model, user can modify the geometry or process condition to improve the quality of products. Next, analyze the revised model and check the analysis result again and again. Repeat the process until the product has fully developed. Okay, and then I will demo the basic functions and the design tools by a simple case. Okay, in Index, we have to open the code file for our simulation and use Model 3D tab to launch eDesignSYNC on left side. Okay, so we can see there are a tree menu on the left side. It includes all the elements of injection molding. Okay, this model is a simple connector with solid runner and cooling channels. In eDesignSYNC, we have to assign the material to each element by easy use interface. Okay. If user want to know the detail of a material, they could open the material wizard to see the viscosity, PVT plots, heat capacity, thermal conductivity, viscoelastic, and mechanical properties, and the conclusion in this material wizard. And Model 3D provide more than 7,000 samples of material in the material database. For this simple connect model, we choose LCP material with fiber content to this project. Okay. and the color will be changed when our set it works. Okay, and then we provide some indicator tools assist the user in performing quick evaluation with their products. Okay. Okay, we can use Get Location Advisor to add gate automatically. If I want to set 2 gates, this advisor will suggest me the suitable position with red color. But in this case, we already have a runner, so I just demo these functions. Okay, we can see there are 2 places we can add the gate. And then the cooling time indicator help us to find the hot spot. And we can reduce the thickness or improve the cooling efficiency for specific position in the red area. Okay. Before mail from enter the cavity, it would eject from mail entrance and then pass through the runner. Therefore, we have to set a runner. And the mail entrance. Okay. After gate or mail entrance set, we can use the LT indicator to check whether the gate location are suitable or not. Okay. And the CMark indicator also to help us to check whether the gate location are suitable or not. And the LT indicator, we suggest that it should under 100. And if the CMark indicator tell me the red area, they have the more probability to cause CMark. Okay. And then we can build cooling system by line element or solid element. Here I built 4 simple line, and we can change the diameter of this cooling channel. Really, okay. And then Model 3D eDesignSYNC provide the automatic mode-based building. Okay, and we can use this function to auto-generate a mode base. And the material of mode base is necessary. In this case, I just use the default one. Okay. And we can see the mode base will execute the overlong cooling channel automatically to let the inlet and the outlet be configured in the mode base boundary. Okay, and we can auto to set the cooling inlet and the outlet after the mode base has been built. Okay, like this. And we also offer a possibility to extend the simulation with over molding and insert molding here and here. We also can set the sensor on the cavity, and it will respond to the pressure or temperature result versus time to users. There is another optional function for advanced hot runner system. Okay. Before the analysis starts, we should set the simulation sequence and the process condition, mesh level, and the project setting, and the report format for our simulation. And we can set the simulation sequence as cool filling packing and warpage filling. The process condition, we should set the filling time, packing time, melt and mold temperature, and cooling time, like this. And for accelerating calculation, eDesignSYNC provides remote computing processing to enhance computation performance, to run an analysis in less time with a more complicated model with large amount of elements. Okay, you can submit the analysis job through the server to manage the speed up the computing processing in higher performance computer. Use this easy dialog, and which reduce the burden of your local machine. Okay. The mesh level, we provide 5 levels of meshing which you can choose from. Level 1 is the most recommended level for the user who want to have a quick filling analysis result. In most cases, the solid mesh generated in this level is applied for demo purpose. Under this level, the program generates the solid mesh with fewer elements and performs CAE analysis with a higher acceleration ratio. Okay, and level 5 is the most accurate level for getting in-depth analysis for all kinds of parts. Under this level, the program generates mesh more elaborate and performs CAE analysis accurately. However, it is to be noted that more hardware resources are required. And then we have to set the saving path. And we also can put a remark on the wrong data on your analysis. Eventually, we provide the report generator for users. Choosing one report format you want, and the report will be generated automatically after the analysis finish. Okay. So for this case, we check an analysis result of this connect model. I prepare a video, is the animation result for the filling stage. Okay, for this connector, we can decrease in the filling analysis result. The melt from time result shows obvious racetrack effect in the filling animation. And the racetrack effect leads to unbalanced flow and may cause even uneven volume shrinkage. Air trap will lie in this part. Okay, so the racetrack effect can be solved in several different ways. For this connect model, we can decrease the thickness on one side of the part to balance the flow. So we use CAD tools to cut a slot on one side of this connect. And we can see the model. I had cut a slot on this wall. And we want to analyze the modified model to confirm that the design change is effective. For comparison, the analysis setup is the same as the original one. Okay, let's examine the result. Okay, we find out that the flow patterns of a melt front is more balanced than the original one. the male front even reaches the end of a cavity almost the same time. So this video is public material, and you can find it in our website. Okay. So except flow balance, user may concern the flow pattern of the male front. When we to show the result of this analysis, we have to concern the location of flow termination and maybe air trap. Okay, and the well line. Okay, so you can better understand how the defects happen and find the solution. Okay, so and then we also can to choose the camping force to refer the camping force result and warpage result to decide the machine types and to revise the process conditions. Okay, so in a simple summary, the integration between design and the simulation create a high-performance design platform that gives designers the ability to examine, optimize, and seamlessly create more designs. Finally, it enhances product quality and reduce cost through eDesignSYNC for NX. Okay. I hope this demo make you know more about eDesignSYNC. Okay, thank you for your attention.